All right, today we are in topic 9, block 12. And in this block, our goals and objectives are to develop a probability model and use the model to find probabilities, represent sample spaces for events, and find the probability of compound events. So, what I want to think about today is the probability when we replace an item whenever we draw something like out of a drawer compared to not replacing that item and how it would affect our probability of possibly getting something later. Okay, so for instance, if um, we had five $1 bills, two $5 bills, and one $100 bill, if we're playing the game and say there's two people that are going to play, and the first person grabs in the bag and gets the $100 bill. But we replace that $100 bill with another one for the next contestant. They still have a chance to do what?
Grab $100.
Yeah, win the $100. Now, if we are going to set up the same experiment, except whenever somebody pulls money out of the bag, we don't replace it and say that first event, the person grabs the $100 bill. Does the second person have a chance to win $100?
No, because there's only one $100 bill and you didn't replace it. So
Correct.
it's gone.
So, this is actually what we're going to be talking about today. Now, in the previous lessons, we always were doing a compound event that was called an independent event, where the first event um, didn't change the probability of the second event. Well, now we're talking about dependent events, and this is where the outcome of of one event affects the probability of the second event, meaning that you do something and it's going to cause a different outcome. All right. So what we're going to do is we're going to look at this first page. If you would, Vincent, would you read this for us, please?
In the prior lesson, you studied compound probability of independent events, where the first event did not change the probability of the second event. Today, we will investigate the compound probability of dependent events, where the outcome of one event affects the probability of the second event. One example of an independent event is when you choose one item and do not replace it before you choose the second item.
So, can you think of a situation like this where making a selection can change the probability of what happens next? This is actually question 1 in your workbook. So, how can making a selection change the probability of what happens next? So, I'll give you an example. Say we're driving down the road and there's a cop behind me and the light turns red. If I choose to run the red light, what would probably happen next?
More cops probably chase after you.
Yeah, well, the cops are going to chase after you. Now, if I would have stopped at the red light, would the cop still chase me?
He would have left you alone.
Yeah, he would leave you alone. All right. So that would be kind of like a real scenario or a real situation that could occur. But think about like games that we play. So similar to what we talked about earlier. Say everybody that gets an A on the test gets a chance to go to the prize bucket where there's a $5 bill, a bag of Takis, a drink of your choice, or no homework. But there's only those in there. And I'm going to pick two people. And so one person goes up and they pick out of the jar and they get something. Does the person that gets to go second, do they have the same chance as the person that went first?
No.
No, they don't. All right, so that would be a situation where it's a dependent event because it's someone choosing an item and not replacing it before the person chooses the second item. Okay? So you were supposed to come up with your own input for question 1. Did anybody come up with one of those? Devin, did you do that?
Yes, I did.
All right, let's hear what you got.
Mine was, say you're playing Among Us, right?
Mm-hmm.
And you get randomized every time if you're the imposter. And
Correct.
in some games, there's only one imposter. So if you get picked as the imposter, then no one else has a chance of getting an imposter.
That is true. That is true. Does anybody else have one or have a question? All right. Let's keep on moving. Let's go to page 2. Layla, who you want to call on?
What?
Who do you want to call on?
Angel. If she's here, I don't know.
Angel.
Can I be excused?
Yes, ma'am. Angel, we want you to read page 2.
All right. Okay. Hold on. Recall
Recall the tree diagram.
diagram you create for the probabilities of picking 3 different colored marbles from a jar. How does the probability tree change when you do not replace the first marble you select? Play the animation to explore the differences. If the first marble you select is blue marble, is a blue marble, and you do not replace it in the container, what are the possible outcomes for the second marble you select?
All right. You did a great job, but I'm going to reread also just because there was a lot of background noise, okay? So, recall the tree diagram you created for the probabilities of picking 3 different colored marbles from a jar. How does the probability tree change when you do not replace the first marble you select? If the first marble you select is a blue marble and you do not replace it in the container, what are the possible outcomes for the second marble that we would select? What do you think, Hamarjane? If we pick a blue marble first, what are the only possible outcomes left?
Probably purple or yellow one.
Correct. That's it. And so our outcome would be what? If we pick blue first, what are our possible outcomes?
Anyone?
Yeah, that's fine.
BY and BP? Or
Correct. So blue to yellow and blue and purple would be our possible outcomes there. All right, let's take a look at what would happen if we were to select yellow first. Sanaya, if we picked yellow, what would be left to pick the second time?
Somebody call on me.
Yes.
You called on me?
You're in class, right?
Oh, yeah, what's your name?
I'm just messing with you. All right, I said if you pick yellow out of the jar the first time and you do not replace yellow, what are the only possible outcomes that you could get the second time out of the jar?
Blue and purple.
Great job. All right, Satari, if you picked purple the first time, what are the only possible outcomes that you could get the second time?
Blue and yellow.
Great job. All right, so there's 3 choices for each first selection, but there's how many for each second selection?
6.
You're right.
But
2.
it's 2 for each.
Yeah,
but
2 for each. But in all, there's how many possible outcomes?
6.
Perfect.
6.
All right, so we're going to name those 6. So, Braden, I want you to name the 6 outcomes.
Isn't
So the first one would be blue to yellow. What would the second one be?
Blue and yellow, blue and purple, yellow and blue, yellow and purple, purple and blue, and purple and yellow.
All right. So how is the sample space affected by not replacing the marble? Like what outcomes are not possible? What will we not get?
Blue and blue, yellow and yellow.
The same or the same color.
Correct. Good
Yeah, we don't
job.
get the same color twice.
Good job. Great job, guys. Y'all got it going on. Now, what would be the possible outcome for getting a yellow purple? What is the chance or what is the theoretical probability that we will get a yellow purple? How would you determine that? How many yellow
1/6.
purples are there? Say it again.
1/6.
Why?
Well, you can do it two ways.
Okay.
The simpler way is you just get yellow purple, and since there's 6 different outcomes, it would be 1 out of 6. And another way you can do it is since there's 3 first selections, that's 1/3 of picking yellow first, and then picking the purple next would be a 1/2 because you have the blue and the purple there. So then you multiply 1/3 times 1/2, and you get 1/6.
Perfect job. Perfect explanation. Does anybody have any questions about that? All right. And this was question 2 in your workbook. If you did not do question 2 in your workbook, this is where you would want to answer it. Okay. Alora, can you read this for us, please, ma'am?
The outcome of the first event affects the outcome of the second event because we are not replacing the first marble we choose. To determine the probability of the dependent compound event, start by finding the probability of the first event. Next, find the probability of the second event, assuming the marble chosen in the first event has not been replaced. Finally, multiply the two probabilities together.
All right. So in independent compound events and dependent compound events, what operation do we have to do to solve to find out what our probability of the compound event will be?
Multiplication.
Do y'all agree?
Yes.
Yes.
Yes,
Great
sir.
job. All right. Looking at this. Takiria, would you read this, please, ma'am?
Okay, I'm about to. Mark is leaving a restaurant and noticed a dish of candy mint without looking. He reached into the dish and take a mint. There are 10 candies in the dish. 1 red, 2 yellows, 3 green, and 4 blue. His sister followed him out of the restaurant and does the same thing. Mark wonders what the possibility is that he took a red candy and then his sister took a green candy.
So, looking at that, Takiria, do you think that these compound events are dependent or independent, and how do you know? Devin, what makes a compound event dependent or independent?
An independent compound event is when it's randomized, and a dependent compound event is when someone picks first and gets there before you do.
Okay. Does anybody have anything to add to that, what he said? So I think of an independent event as an event that occurs and then the item is replaced. And then the next person that goes has the same opportunity as the first person. A dependent event is when an item is taken and it's not there anymore. So the next person that goes doesn't have the same chance of getting what you got. So out of those explanations, Takiria, do you think this is a compound event that is dependent or independent?
Dependent.
It is dependent. You're correct. Why is it dependent? Why is it dependent, class?
Because Mark takes one candy out, there are still a few of the candies left.
That's right. And does Mark replace it?
No, he eats it.
That's right. He eats it. So this is a dependent event. Good job, Takiria. All right, Tamarian. What's the probability that he's going to choose a red candy?
Sir?
What is the probability that Mark chooses a red candy? He wants this red candy right here. What is that probability?
1.
Out of how many?
Mm, 10.
Correct. 1 out of 10 chance. Now, he just ate this. So it's gone. All right. Now, what, Sophia, is the chance that his sister gets a piece of green candy?
1/3.
How?
Because there's 3 pieces of green candy.
Okay. I see 3 pieces of green candy. Out of how many?
10. Oh, 9.
9. I was about to say, how do you get 1/3 if the denominator's 10? So how do you make 3/9 become 1/3, Sophia? What do you have to do?
Wait, can you say that again?
How do you make 3/9 become 1/3? You said that our answer was 1/3. I agree with you. I just want to know, how do you make 3/9 become 1/3?
Don't you divide it by 3?
That's right. You just divide both the numerator and the denominator by 3. And whenever you do that, you're going to get that answer right there. Right? 3 divided by 3 is what? What's 3 divided by 3?
1,
1. What's 9 divided by 3?
3.
All right. So let's do this. Khalees, what's 1 times 1? Help her out, Layla. What's 1 times 1? If you have one group of 1, how many do you have? Oh, I'm in strike 2. Don't let me strike out. Satari, what's 1 times 1?
I was trying to answer, my thing wouldn't stop.
Oh
Oh my God.
Well, what's the answer going to be?
I don't know, 1.
Yes, it is. Great job, girls. All right, 1 times 1 is 1. And what is 10 times 3, Brendan? If you have 10 groups of 3, how much do you have?
30.
30. Great job. So our chance, or their chance, that they will get a red and a green by picking this without looking would be a what chance?
1/30th.
A 1/30th chance. Is that a very likely probability?
No.
No, not really. That's pretty unlikely. All right, take a look at this one. Akira, I want you to read this for us, please, ma'am.
Complete the puzzle to find additional probabilities of events when candies are taken from the dish and not replaced. Remember that Mark reached into the dish without looking and took a candy, and then his sister followed and did the same thing before Mark chose one. The dish held 10 candies, 1 red, 2 yellow, 3 green, and 4 blue.
All right, so looking at this. If he chooses this, what is the chance that he will get yellow, Akira? I should say yellow. They're going to know where we're from. What is the chance that he will get a yellow candy when he draws out of the bucket? Help her out, Vincent.
Wouldn't it be 2 out of 9?
All right. I see 2 yellow candies. I agree with you. Well, let's count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go ahead, Vincent.
10.
There are 10 of them. So it would be a what chance?
30%. 3 out of 10.
Well, it's a 2 out of 10, which would be how many percent?
20.
Yeah, 20%. But there's no 2 out of 10 on here. So what are we going to have to do to 2 out of 10 to get our answer?
That's why I was confused.
That's okay. What am I going to have to do to get our answer?
You could do
Correct. We're going to divide by 2. And what is 2 divided by 2?
1, and then 10 divided by 2 is 5, so the answer would be 1/5.
Perfect. All right. Devin, what is the probability of the second choice being blue? Can't hear you.
Since a yellow is already gone, there would be 9 candies left, so it'd be 4 out of 9.
Correct. All right. Now, with that being said, Braden, what do we have to do to find the compound probability? What operation do we do, Braden? Add, subtract, multiply, or divide? Braden, quit playing video games. Pay attention. Help him out. That's right. We're going to multiply. So, Hermione, what's 1 times 4?
4.
And what is 5 times 9?
45, I think.
You are right. All right, let's look at the next one. Sophia, what is the chance if the brother goes up there and he picks a green, the first probability, what is the chance that that would occur?
3 out of 10.
Correct. What is the chance that after he picks that, his sister gets a green? Help her out.
There is no.
You don't think so?
2 out of 9,
All right. Why do you say it would be 2 out of 9?
because since a green candy has already been taken, you would mark out a green candy, and since there's 9 candies left, there'd be 2 more green candies left, so it'd be 2 out of 9.
All right. Do y'all agree with that statement? All right. So how would we find our answer? What would we have to do? Together, what do y'all think?
Multiply.
That's right. We're going to multiply. So when we do that, what are 3 groups of 2, Satari? Or 3 times 2? Help Satari out. If you have 3 groups of 2, how many do you have? Go ahead, boy.
6.
Correct. We have 6. All right, I don't see that answer up there, so I'm going to put my 6 here. If we have 10 groups of 9, how many is that?
90.
Good. And so when we have 6 90ths, Sophia told us earlier that we could simplify by dividing. So what can I divide the numerator and denominator by to simplify this?
6.
Correct. And 6 divided by 6 is what, class?
1.
And 90 divided by 6 is?
15.
Great job. Anybody have a question? Vincent, you got a question or you're giving me the answer?
I was raising my hand to answer.
All right. What was the answer, man?
1/15.
Why was it 1/15 instead of 6 90ths?
Because because we simplified it.
Perfect. Vincent, go ahead and read this for us.
There are 9 girls and 15 boys in Miss Bernard's 7th grade math class. She needs 2 students for a project. She writes the name of each student on separate pieces of paper and put them in a box. Then she draws 2 names out of the box. What is the probability of Miss Bernard choosing 2 boys?
All right. So, looking at this, Khalees, what do you think the chance is of picking a boy first? And if you're not sure of that, what I want you to first think about is how many kids are in that classroom in all. Khalees having a hard time talking today. I don't know what's going on. There she is. I'm starting to hear her. Go ahead, Khalees.
24.
Great job. And how'd you get 24?
I added 15 plus 9.
Great. So there's 24 students in all. So what is the chance that Miss Bernard will pick a boy the first time?
15.
That's right, 15 out of 24. Now, can we simplify 15 24ths?
Yes.
Yeah, what can I divide them both by?
3.
I can divide them both by 3. 15 divided by 3 is what?
5.
And 24 divided by 3 is?
8.
Great. So I'm going to take this, and then I'm going to see what the next chance is to get this boy. So now I don't have 15 boys anymore. How many boys do I have? I got 14, and I don't have 24 people there anymore because I got rid of one of them because they were acting up. I'm just kidding.
So 23.
23. And so, since this is a compound event, how do you determine the chance that she will pick 2 boys?
Multiply.
That's right. Now, we could do some simplifying to make this easier, or we can go straight across and multiply and then simplify. It's y'all's choice.
Solve it first and then simplify.
All
Yeah.
right.
Solve first and
So,
simplify.
so let's do this. How do I multiply this? What am I supposed to do?
Go straight across. So 5 times 14 is 70.
Okay. And then what do I do for the
And
denominator?
8 times 23 is 184.
Okay. So what do y'all think these are divisible by, class?
70.
Well, I tried it earlier and it's not divisible by it.
By 2.
It is divisible by 2. Good job. What is 70 divided by 2?
35.
Good. And what's 184 divided by 2?
92. 62.
92.
92.
Yeah,
Good.
yeah, 92.
Because 4 divided by 2 is 2 and 18 divided by 2 is
9, yeah.
9. All right. Now, for those of y'all that I was talking about earlier about simplifying it first, we could have divided 14 and 8 by 2. And so this would have gave us 4. And this would have gave us 7. And 5 times 7 is 35. And 4 times 23 is 92. That's kind of neat too, huh?
Yeah, a little bit.
All right. It makes it a little bit simpler sometimes where you can do it in your head. On a number like this is a little large, so it's kind of hard to do. The only way that you can do this mentally is to do like 4 times 20. You know that's 80. And 4 times 3 is 12. So 80 and 12 make what? 80 and 12 make what when combined?
92.
92. So that's how you could do that mentally. All right, let's take a look at our summary. So if you would you please read this for us, Mr. Brendan?
Sometimes compound probabilities are dependent. The outcome of the first event affects the outcome of the second event. To find the probability of the dependent compound event, first find the probability of the first event. Then find the probability of the second event, assuming the first event has occurred. Finally, multiply the two probabilities together.
All right. So looking at this, anytime we have an outcome of the first event that affects the outcome of the second event, that's called a what kind of compound probability? What kind of compound probability? When the outcome of the first event affects the outcome of the second event?
Dependent.
All right. What about when the outcome of the first event does not affect the outcome of the second event?
Independent.
All right. So, what is the key thing that lets us know if there's an independent versus a dependent?
If it's replaced or not.
Correct. If it's replaced, it is what?
Independent.
And if it's not replaced, it is
Dependent.
perfect. So that is the difference between independent and dependent compound probabilities and how replacement and non-replacement affect that. All right. So we've already talked about some real life examples of with or without replacement. That's kind of what I talked about earlier when we were driving in the car and the policeman was behind us and I decided to run the red light. The cop is going to write me a ticket. If I would have stopped, then the cop would have just kept driving. All right. So now, with that being said, that is the conclusion of this lesson today. However, you have two questions that are going to be put in your agile mind for you to complete right now. And so I'm going to do that right now for you. Now that these are being set up for you to do, what I want you to do is I want you to answer questions 11 and 12. If you are at home and you don't have these questions, you can look them up on the guided practice. That's what these are, the guided practice questions. And so this is guided practice questions 11 and 12. You're going to do that for me for a grade right now, and you can locate that by going to guided practice questions 11 through 12. This will be open until the 5th. So you have until 6 p.m. to do this tomorrow. And so that's going to conclude our class today.